from a metric standpoint, our take on this was it's less to do with the creativity of the solution. It's more about as the model was trying to come up with its answer, how confused was it? Right? It's almost like if you go to a creative person, like a poet, and just tell the poet, like, "Hey, write a poem about birds." The poet might come up with a great poem because it's been trained. He or she's been trained with a lot of information about birds. Now you go to the same poet and say, "Come up with a poem about quantum classifiers." The poet's going to have a really hard time in stringing together a poem. So that's what we look at. We look at like at a word per word level, what's the probability of the response? And if it's having a really hard time stringing together a sentence, that's when we know the confusion is high. And so the probability of confusion is also pretty high. And that's what we call low correctness and our hallucinations.
Synthedia.
I appreciate you being here. We just had a really interesting conversation around testing. So we talked to some of the foundation model companies. We actually have one coming up. If you're in the audience too, we're going to talk about OpenAI models as offered by Azure in just a moment after Vikram and I talk. But we talked about foundation models. We talked just now about testing, and it's like, how do you make the model better? Like from a user experience standpoint, mostly. But you have a different take on this in terms of how you make the model better. And if people don't know, Vikram was at Google AI, was working on large language models that were specific for some industry domain applications and things like that. And then I guess at some point the light bulb went off. It's like, oh, how are people going to determine if these things are good or not?
That's exactly right. Yeah. So I've been in the language model space, I guess, for the last 4 or 5 years, working with transformers on smaller language models initially, where the inputs were, I guess, easier, just the quality of the data, if that's good or not. But the outputs were labels. And now I feel like it's just exploded so much more because the outputs can be so probabilistic. My take on this has been since day one that if you want to evaluate and test stuff, you need metrics. You can't just be, human evaluating. It's too expensive. It's too time consuming, and it's also leads to biases. So you have to have, world-class metrics to be able to evaluate the inputs and evaluate the outputs. That's the only way you can achieve automation in the workflow.
Yeah, perfect. Okay, so I think you're going to show a couple of things.
Yeah, that's right. So I was going to maybe present my screen and walk through what me and my team at Galileo have been doing. So we started Galileo initially as a research shop about 2.5 years ago to focus on exactly this problem, right? Like how do you evaluate your inputs? How do you evaluate your outputs? And it's an experiment bench essentially for any data science team that's building LLM powered applications, so that you can build trustworthy LLM applications that do not hallucinate. So what I'll walk through is at a high level what we're seeing in the market around the stack and where the big pain points emerge today. And I'm actually also going to do a quick demo if you have the time for about like 5 minutes, 10 minutes,
Go
and
for it.
walk people through it. So think of Galileo as an evaluation first platform for LLM application development, right? The keyword here is evaluation and testing, and we're being used today by data science teams across a whole swath of organizations, some very large organizations, some mid-stage companies. But the common theme here is all of these businesses have data science teams that are working on leveraging large language models for some very business critical applications, pre-production, and some of them are in production at this point. Across the board, the common stack that we've been seeing emerge is something like this, where you have an ML platform at the bottom. You could be, SageMaker, it could be Azure AI, Vertex AI, etc. And then you have a whole host of LLMs to choose from. At last count, when I was looking at the Hugging Face leaderboard of popular LLMs that people are using today, the count was beyond 250. So you have a lot of options. And the question becomes like, for my use case, let's say it's generating text or summarizing large blogs. For this particular use case, what's the right LLM to use? The next question becomes, great, but now I have all these prompts that I'm trying out. I change my prompt just a little bit, and now the output is completely different. How do I experiment with that, right? So you need to experiment to find the right LLM, the right prompt as quickly as possible. But also the problem is when you do look at the text generation or the summarization or the turn-by-turn chats that are being produced, how do you know if it's actually correct or if it's actually moving the right direction? or not. And today it's just happening just by eyeballing. So there's no reliable metrics today at all for evaluation. People are just eyeballing Excel sheets, Python notebooks, etc. That's the that's the state of the art of evaluation and testing today. Um, Vector databases are used a lot for RAG, which is great for kind of grounding the model in some context. But even there, like, how do you know if you have sufficient context, if you have some output from the model which is not grounded in what the context was provided in the first place? So the model's basically out of syllabus or hallucinating at that point. And eventually, when you actually put something in production, how do you know if there is hallucination happening in production? It's super harmful for your brand. How do you know if there's some toxicity in the output, PII data leakage, etc.? So, in order to solve for all of this, essentially the solution that our product company has is called the LLM Studio, which we launched a couple of months ago. Where it's a complete end-to-end solution for evaluation, experimentation, as well as observability, right? So there's three different parts to this. There's a prompt aspect, there's a fine-tune aspect, and a real-time monitoring aspect. And what I'll do is I'll actually walk through all three of them in a quick demo as well. But essentially, what happens because of this platform is because Galileo hooks into the LLMs as well as the vector context and the production application gives the data science team this 360-degree view about exactly what's going on with their prompts, automatically version controls those prompts for the users, but also helps you work with the highest quality data, and eventually make sure that you're monitoring your prompts and your outputs from the model in production. The whole goal here is to be able to go from high ROI idea for an application to actually a production app super fast, and then have feedback loops so that you can fix the prompt or fix the data really quickly as well. So there's again three different products, and I'll walk through each of them really quickly in a demo as well. First one is called Prompt, all about experimenting across the plethora of different inputs that you have, right? Like the prompt itself, the LLM parameters, the RAG context, the context parameters. There's a whole host of them. How do you experiment there? And then on the fine-tune side, how do you find the right the problems in the data where the model was having a hard time? And finally, real-time monitoring. And the main thing here in all of this is you can have an experiment bench, you can have some software can do slice and dice all of this, but without metrics, none of this matters. And so that is the point of view that we come to the table with, where you need to have a guardrail metric store. And this is super important, um, because without these metrics, you're just flying blind. So that's been a big part of what Galileo has been doing since day one, and we think of this in across three different kinds of domains. So the first category is LLM output and hallucination guardrails, right? Which is the leftmost one over here. Now, for LLM output and hallucination, what we realized was the existing metrics just don't cut it. They just like blue and rouge, etc. They're very low level metrics. They're all about the semantic understanding of the ground truth and the model's output. Very low level metric. And so we had to build metrics from the ground up, which I'll talk about in a second. So there's LLM correctness and LLM uncertainty that Galileo provides out of the box on a per word token, or on a per word level, to kind of help you understand specifically where the model is having a hard time. You need to have PII detection, bias detection, etc., baked in so that you can get a quick sense of whether you're moving the right direction or wrong direction. Second category is vector context and training data guardrails. So we have this metric called data error potential, which has become an industry standard at this point for how do you quantify data quality. We call it the DEP score. So this basically tells you what data amongst the thousands of data points you're fine tuning your model with specifically has an issue. You can have for the context itself, you need to have a sense for what we call context adherence, which is let's say on a score of 0 to 1, how adherent is your output to the context that was provided for RAG, right? Super important, because if it's very out of context, let's say that context adherence score is 0, That just means that it's not following the syllabus that you provided it with. At scale, that can be a big problem. Similarly, context sparsity, like how much context did you actually get back from the vector database? Context relevance, which is the how relevant is the input to the context that was provided by the model. So all of these metrics kind of give you a different vantage point to kind of look at the model's output from. Apart from that, we've also seen a big need for custom guardrails, right? Like every single team, every single project has its own small nuances. One of the financial services companies in EU that we're working with, they're really worried about the EU AI Act that's coming up. So the question there becomes, like, can we convert that into a bunch of custom metrics and just present that back, add that back into this evaluation framework, so we always know that we're compliant or not. But it could be something much simpler than that. It could just be a bunch of words that you just don't want to see in the output. And if you ever have them show up, then you want to just be flagged, those be flagged for you. So these three are these three are the big um, categories that we think about when we try to think about how people should evaluate and experiment their different models. Um, Now, towards that end, we realized that there was a big need for, coming up with these metrics ourselves, just given that none of these metrics, especially on the output side, exist. Right? There was a stock which just before this, where we were talking about how there's a lot of uh, probabilistic results in the output. So it's very hard to see if a generated text um, is actually correct or not. Our take on this has been we've done bottoms up research. Half of our team is ML research that's thought about how let's detect how confused the model was as it was coming up with a certain solution. So one of the papers that we very recently published is called chain poll, which is this methodology that we've used to be able to quickly figure out whether the model's output is correct or not, which is kind of the measure of the confusion of the model as it was coming up with the solution. And what we've seen through our different experiments is this metric of factuality, which is if you don't have RAG, or groundedness, which is if you're using RAG, which both of these metrics use chain poll. What we noticed from this is we achieved about an 85% correlation with human feedback with these metrics, which is huge because now a lot of our users don't have to have humans as the first line of defense. They can have this metric as the first line of defense, but then you have to have humans as evaluators. But that should be kind of like your second phase of QC, right? Shouldn't be your first. So that's where we've seen huge time savings and cost savings just by using these state-of-the-art metrics for output evaluations. Um, in terms of how this actually manifests in the product, right? There's three different parts to this. One is prompt itself. So in the prompt, when you were, let's say, prompt engineering in a notebook, you can quickly get a sense for in the UI, specifically what's the generated output and where in the output was it having a hard time, as well as because the technique that we use for these metrics, like the groundedness metrics, because the techniques that we use are use chain of thought prompting behind the scenes. We we can get a sense from the model about its rationale and its reasoning for the response, and so we basically provide that back to the data scientist, right? Where in the UI itself, they can get a sense for why the model was providing this particular response. It helps with debugging quite a lot. It's almost like having the model by your side as you're debugging its own outputs, which has been hugely powerful when it comes to trying to provide get some insight and explainability into how the model was coming up with its responses. Um, the second is on the fine tune side, super important to be able to not just visualize all of the data that you're fine tuning your model with, but also you can use the data error potential score that I mentioned before to be able to quickly get clusters of data that are problematic for your model. And this dramatically short circuits, you're looking at 10,000 different data points to try to find out a needle in a haystack around exactly what data you can remove, what data you need more of, etc. To just focusing on the clusters of data that your model was having a difficult time with. So all of that is on the fine tune side. But even though you might have all of these guardrails in place, what we've noticed is you can still, when the rubber hits the road and the model hits production, that's when everything just starts, right? And you need to make sure that you have all these guardrails, custom metrics, etc., in place for that moment, so that you can quickly figure out what's hallucinating, quickly figure out where the model was having a hard time, and then be able to siphon off the data which was tough for the model to fine tune with again. That feedback loop in machine learning is super critical. I think that's the holy grail eventually, like not just getting to production. Getting to production is just step one, but it's beyond that is where beyond that is where you need those feedback loops to come in. So all of this was great in slides, but I wanted to show the audience was an actual demo of the product to walk through how people can experiment in a much more rapid way. Whole goal is really to take folks out of just using notebooks and sheets to experiment, but up level data science teams so that you have almost like this data science bench with a copilot induced in it, powered by metrics, to help you get to the best prompt as quickly as possible, help you get to the highest quality data to fine tune with as quickly as possible. So towards that end, one of the applications which I was building over the weekend is a Q&A app for kids, right? Super simple application that a child comes in, enters certain questions, gets a response from the model. I loaded a bunch of prompts in here from the Stanford Q&A dataset. I used Pinecone to just add a bunch of context, just basically Wikipedia articles that I threw into Pinecone. And then that's it. I just started creating prompt runs with Galileo. I added one prompt run here with this template where it says, "You're a helpful assistant. Given the following context, please answer the question." The context comes from Pinecone. The question basically is all of the prompts that I loaded up here. And after that, I just simply add all of the metrics that I want to use, like groundedness, which is the metric for how the LLMs how grounded was the LLM output uh, in the uh, in the context that was provided, and factuality, which is the North Star metric for how correct was the model's response or how confused was the model in its response, as well as a few others. Plus, I also have, let's say, somebody from a compliance side telling me that, look, there are certain words which I want you to be careful about. I don't want those words um, to be surfaced in the model's output. And if those do show up, then just let me know. Return a one or otherwise return a zero. And I call this the bag of words metric. And I register that with Galileo as well. And that's it. I now give it a project name and mention that, hey, I want to use ChatGPT 16K here. And once I'm done with that, I get a link to the Galileo run. When I do this, essentially, I get to this run here where I can very quickly see the a bunch of metrics on the top. One of them being the factuality metric, where this is the measure of the model's correctness. And I can see that it's not a one. A one or close to one would be ideal. So already I can see that something's wrong. The groundedness is also close to 0.79, which is not ideal, which means that the context I provided is probably not sufficient because the model's output is not grounded completely in the context that was provided. So this already generates some red flags in my head around I need to look into why this is happening and how I can improve it. And you can see here that when you're looking at the output of the model for the input that was provided, with all of these metrics that are here, I can see that there's one of them, for instance, here, which says the factuality is zero, the groundedness is zero as well. So I can click on this. And when I look at this, it basically says, you know, the yeah, talks about how the weather it talks about the weather in a certain part of Victoria, um, which is basically a part of Australia. But the average temperature in the summer is above 32. In the winter, it's above 15. Um, but the question that was asked is, what's the median temperature in the winter? Now, without Galileo or any such evaluation platform, it's you just basically look at the model's output, and try to figure out if that's correct or not. We did that, and we saw that it says the temperature in the winter is around 15 degrees Celsius, which matches with what we see over here. So it's easy peasy, thumbs up, good to go. Go to the next one. But because we have metrics, right, the factuality is zero here, it gives me some pause and it forces me to think about why that happened. Now, again, if you remember, I mentioned that this metric is powered by chain of thought prompting behind the scenes, amongst other things. Um, because of that, I get an actual response from the model back about its rationale for why the factuality is zero. And so this becomes super interesting from a debugging standpoint, where you can start to see in this last few sentences where it tells you that the question asks for the median temperature, not the average temperature. And without additional information or data on the distribution of winter temperatures, it's not possible to determine what the median would be. That's when you realize that all of this information here in the context is about the average, but what the question was about the median. And so essentially that becomes super important for me to add more context about median temperatures. So I can mark this as a thumbs down and move on to the next one and the next one after that. And as I do this, I can get further explainability using token level uncertainty scores, which becomes super interesting for users for further explainability.
Yeah,
So
this is great. Is there something else I want to like ask you a couple questions before we have to
yeah,
wrap up?
yeah, for sure. So yeah, I just wanted to wrap up by saying like this is a quick way of showcasing how you can go from not just using notebooks and using Excel sheets, but up leveling ourselves using an experimentation platform. But most importantly, it's about all the metrics that you use and that you surround yourself with. Otherwise, we're just gonna be using humans for evaluation, which is not great for society.
Yeah, exactly. Well, we don't do a very good job of that, and you can pull that down now. So like you can I just a little chat.
Yeah,
Paul Sweeney in the audience said this is really a fantastic product.
thank you.
Real time
Appreciate it.
validation from the very erudite viewers and audience of Synthedia 4. Steve King has a question too. How do you differentiate in real time between hallucinations and creativity when some prompts require accurate fact based output and others may drive output that's a combination of facts and creativity?
Yeah, it's a great question. So there are a couple of different aspects to that. One is you might, as a user, want more creativity, right? In which case you might
Yes.
want to put the temperature as zero. There's more creativity happen. Or sorry, temperature is one, in which case the model is coming up with more creative answers. Um, the From a metric standpoint, our take on this was it's less to do with the creativity of the solution. It's more about as the model was trying to come up with its answer, how confused was it? Right. It's almost like if you go to a creative person, like a poet, and just tell the poet, like, hey, write a poem about birds. The poet might come up with a great poem because he or she's been trained with a lot of information about birds. Now you go to the same poet and say, come up with a poem about quantum classifiers. The poet's gonna have a really hard time in stringing together a poem. So that's what we look at. We look at like at a word per word level, what's the probability of the response? And if it's having a really hard time stringing together a sentence, that's when we know the confusion is high, and so the probability of confusion is also pretty high, and that's what we call low correctness and or hallucinations.
Yeah, and there's another question from the audience about why the models don't provide metrics themselves. And I think this is maybe a little bit more complicated because it would be useful within the model itself to provide more visibility, but they don't provide a lot of data to the users. Usually it's obscured. Uh, but even then, even if they did, they would show metrics differently, so it would be very hard to compare
Yeah,
across models. So in one case, it would be great if they did, because like versions of the model, you would have some
yeah.
sort of truth that you could measure against. But like if you're looking across models, probably that would never happen.
That's true. That's true. And models, especially the open source ones, they are pretty open about the some metrics that they provide, but you can't just use that and figure out if the model is giving a good output or not. Like they give you log probabilities for every word, but that by itself is not good enough. You have to kind of string it all together to make sure that how confused is the model across an entire blog that it generated. Um, so they do, but you're right. Like it's not at the level where we can actually consume that and feel like that's actually sufficient. The same thing had happened with models in NLP before, with smaller models where you had precision and recall, which could be derived from the model's output, but then we had to come up with the F1 score, which the industry gravitated
Right.
towards as the North Star metric, and that's not happened yet. And that's where the correctness metric from Galileo is proposed as one such metric.
Yeah. And so if we just sort of build on that a little bit, some of the models provide more information than others.
Mhm.
So if you're working with particularly the proprietary models that provide very little information, you don't see the probabilities, those types of things.
Yeah.
How do you actually generate these metrics without any information directly from the model itself in order to feed your system?
Yeah, so that's exactly right. So that gets tough. So what we do instead is what we realized is depending on the prompt that you have, you can easily um, use a lookalike model. So like for instead of GPT 3 point, instead of using GPT-4, which is super expensive and also super closed source, doesn't give you anything. What you realized is you use a different kind of GPT model, the Curie model, which has got the same underlying architecture, but just being trained on fewer tokens. So the places where it gets confused is exactly the same. So by using those kinds of lookalike models, you can get a very good sense for the model's confusion using that chain pool technique that we described.
Yeah, and then in terms of the metrics that you've talked about, because you talked about a lot that I think are really, really useful. Um, how do you normalize that across models?
So we essentially did a bunch of in our experiments and result in research. What we did was we used about I think 1 to 2 dozen different kinds of data sets, as well as different kinds of use cases, right? Like Q&A, summarization, with RAG, without RAG, etc. And then we had to figure out if this is consistently at parity with human evaluation. Our KPI was above 85% correlation with what a human would have said as, yeah, this is hallucination, this is not a hallucination. That's kind of how we came up with that metric. And then what we saw is by doing that, when we use this across different kinds of models, because it's basically math at the end of the day, it just works across different kinds of closed source or open source or custom LLMs that have been fine tuned.
Yeah, absolutely. And why is the term metrics? I mean, like when people say, "Oh, we need metrics," right? So really, what you're talking about in terms of that, like, why do you use that term? Is that because you could have used other terms? Why do you use that term?
Because I think at the end of the day, a data scientist and my team at Google was doing a lot of data science, and data scientists' jobs like they emerge from experimentation. It's all about experimentation. And so when you're experimenting in a lab, right? If you're in a chemistry lab and you're experimenting with sulfuric acid and stuff, you have to write down like what was the number, and the number is a metric, and see that's how you derive success. And so for us, it was like if you're building an experimentation bench for data scientists, then you give them the metrics to be able to people would mention that, hey, is this good? Is this bad? I need a 0 to 1 answer that I can actually comfortably rely on. So it was just a natural extension of, thinking of this whole thing as an experiment bench for data science
Exactly.
teams.
Exactly. Because we had some questions about that as well in terms of like why you think about it that way. And then I just want to ask you a final question here about monitoring. You said like very critical. I think about this whole idea right now. People are implementing this technology, many for the first time, so they don't know how to evaluate. They don't know how to select, and so this
Yeah.
is a great way to do that. You mentioned this whole idea of all these different types of tests and like what are appropriate for your use case. So that's like really critical. Fine tuning, making it better. How do I know if my fine tune model is better than the base model? How do I know if my second fine tuning or retraining or pre training, those types of things that we're doing? But the monitoring is really interesting because we haven't really talked a lot about regression, particularly if the model is a
Yeah.
learning model and not a static model. Uh, I just wanted to give you a chance to sort of talk about that and what you've seen because you've had some history with this and offer a perspective on what people need to be doing now in order to be prepared and to accurately monitor their models.
Yeah, absolutely. So I think there are two big parts to this. One is if you're using, um, I would say like loaned models, right? Like OpenAI's models or like an open source models. I think of those as loaned models because there's somebody else behind the scenes who can just change the data that they pre-trained it with. And
Right.
now you're going to suffer at the end of the day. So when you do that, it's very important to notice drift in terms of these metrics again. Like your hallucination could be awesome, could be really low, and then all of a sudden spike up if they change the data that they pre-trained with. So that's one that you have to be constantly aware of, and you have to constantly monitor that and be alerted about that if that goes up. Again, how do you get alerted? You need metrics that you can rely on, like the correctness score. If that goes really low, all of a sudden, alert me about that. Send me a text message, and I can see the data. The second piece here is having custom metrics is really important in my opinion, like because every product that you're building out is very unique, and you will have certain certain business metrics and certain other keywords that you want to be careful about. And so you want to bake those in as well. And when the rubber hits the road, you want to make sure that those are not being flouted. And the last thing I'll add is monitoring becomes really important because that's the only way you'll know what's not working. And you need to know what additional data you need to fine tune with. You need to know what uh, changes you need to make in the prompts. And at the end of the day, our goal with Galileo is to be able to automate that, to be able to tell you, like, Brett, if you're building an LLM app, you just productionized it, you should get a text message which says, Brett, we have 100,000 new data points that you should fine tune with again, and you can go in and look at it and very quickly do that. So just automating that entire system is very important.
That's awesome, Vikram. Thanks so much for sharing all this. I've heard a lot of really positive comments here in the chat. How can people check out Galileo?
Yeah, so just go to rungalileo.io. That's our website, and there's a lot of information there. And just there's a button called Get Galileo, and as soon as you click that, you'll be able to try us out.
Perfect. Vikram Chatterji, thanks so much for joining me today.
Of course, Brett. It's been a pleasure. Thanks for having me.
Synthedia, the business and technology of generative AI. Generative AI, synthetic media, large language models, image generators, virtual humans, voice clones, deepfakes, ChatGPT, and more.